Hi everyone. In this video, we're going to be doing A-level Maths 9709, paper 53, Probability and Statistics 1, October, November 2025. This paper is 1 hour 15 minutes long, so we'll try to finish within that time limit. So let's get started. Okay, so for this first question, we're told that there are a large number of students at Greenfield College. Each student travels to college by car, by bus, or on foot, independently of any other students. So this last keyword, it basically says that all these probabilities, the probability of traveling by car, by bus, or on foot is independent from each other. Okay. And then we're told that the probability that any students travel by car is 0.4, and the probability that any students travel by bus is 0.35. So we're given two probabilities out of the three probabilities. Okay, for the first part, we're told that three students from Greenfield College are selected at random. Find the probability that none of these three students travel to college by car. Okay, so um, we must. Okay, so here we have a fixed number of trials, which in this case is the three students chosen at random, and we need to find the probability that zero students travel to college by car. So this is just a binomial distribution where n is 3. Probability of success is traveling by car, which is 0.4. So we just want to find the probability that x is equals to 0. So to find this, it's really simple. You just have to take the probability of not traveling by car, which is just 1 minus 0.4, or 1 minus 0.4 to the power of 3. There's no n choose r or all that for this case only. And yeah, you can just type it into your calculator. Give me a while. And your final answer would be 27 out of 125. Always try to leave an exact form as much as you can. Or you can also leave it to 3SF, which is also the exact answer. So yeah, these would be our final answer for the first part. Let's move on to the next part. Okay, so for this second part, we are told that 11 students from Greenfield College are selected at random. So this is most probably going to be a binomial distribution question again. And we're told to find the probability that fewer than 9 out of these 11 students travel to college by car or by bus. Okay, so here, as I said, this is a binomial distribution, and our probability of success would be the probability of traveling by bus and by car and by bus. So to find that probability, you just add up these two probabilities in here. So probability of success would just be 0.4 plus 0.35, since these probabilities are independent, are mutually exclusive. So we follow the addition law. So our probability for this binomial distribution would be 0.75. So n would be 11, and probability of success is 0.75. Okay, so we need to find the probability that fewer than 9 out of the 11 students. So the probability that x is less than 9, not less than or equal to, less than 9. All right, so to do this, since it's a really huge number, um, Okay, so let's think about the numbers that we can have when it's fewer than nine. So fewer than nine can mean one, two, three, all the way until eight students. They travel to college by car or by bus. So we can either add all those individual probabilities up from one to eight, but that is really troublesome. So another option would be to subtract one from the probability that x is equals to 11. So all of the students travel to college by car or by bus all the way until probability that x is equals to 9. So basically, you minus all the probabilities that are not part of that don't fit your criteria in here. So you do that when your number is very close to n. Or you can, just add up all the probabilities from 1 to 8. All right, so now let's compute the individual probabilities in here. So to compute binomial probabilities, you can go to your MF19. Wait, sorry. You have to go to probability and statistics and go on the binomial distribution. Okay, give me yeah, so for binomial, this is the probability function. So P subscript R is, you can see is n choose R times P to the power of R minus 1 minus P, which is the probability of failure to the power of n minus R. So in this case, R is just the value of X. Yeah. Yep, it's the value of X in our case. So this is going to be 11, choose 11 times the probability of success 0.75 to the power of R, which is 11. We don't need the probability of failure because it's just going to be 0, and anything to the power of 0 is just 1. Let's do it for our other two probabilities. So 11, choose 10. Probability of success 0.75 to the power of 10 times probability of failure, which is 0.25, which is 1 minus 0.75. To the power of 1, which is from 11 minus 10. And then lastly, we have 11 choose 9 times 0.75 to the power of 9 times 0.25 squared. And yeah, you can just type all of this into your calculator directly. 11 choose 10, 0.75, 25 minus 11 choose 9, 0.75 to the power of 9 times 0.25 squared. So you would get 0.545 to 3SF as your final answer. So yeah, this would be the final answer for this entire question. Let's move on to the next question. Okay, so for this question, we're told that the Splash Club has 26 members, of whom 16 are swimmers and 10 are divers. No member is both a swimmer and a diver. Okay. The club committee consists of 6 of these 26 members. So out of the 26 members, 6 are chosen to be part of the committee. So we need to find out in how many ways. So since here order doesn't matter, this is definitely a combination question. So it's not a permutations or arrangements question. So in how many ways can the club committee be selected? So this is another keyword to know whether it's a permutations or permutation or combination question. So it's a combination question. So be selected if it must include at least 2 swimmers. So this is one condition, and at least 2 divers. All right. So, okay. So to do this type of combinations question, yeah, we should first try to list down all the possible combinations that we can have, like how many swimmers or how many divers, right? So, okay, so let's just draw 6 slots. Okay, so we must have at least 2 swimmers and 2 divers. So this is the minimum requirement. Okay, so these 2 empty slots, uh, first case is we can have 2 more divers. So the first case is gonna be 2 swimmers and 4 divers. Okay, and then just continue on while keeping the base condition, which is 2 swimmers and 2 divers, and then just fill up these, these 2 empty slots. Okay, so obviously the second one is we can have 2 swimmers. Okay, so this is 4 swimmers, 2 divers. So it's basically the opposite of our previous case. And finally, um, we can have 1 more diver and 1 more swimmer. So this is gonna be 3S, so 3 swimmers and uh 3 divers. Okay, let's see if there's any other way. Yep, yep. I believe these are all the combinations that we can have. All right, so let's find the number of possible selections for 2 swimmers and 4 divers. Okay, so 2 swimmers, 4 divers. So to select the 2 swimmers, we can only select from 16 members who are swimmers. So this is going to be 16 choose 2, since you're choosing 2 swimmers, and then you multiply it, since after choosing the 2 swimmers, you're going to choose the divers. They're not mutually exclusive, right? Just like probability. Okay, so divers you can choose from 10. So because of 10 divers, choose 4. Yeah, so for this, you're going to have 25,200. And then for the case where we have 4 swimmers and 2 divers, yeah, again, this is mutually exclusive, so we're gonna have 16 swimmers and 10 divers at the beginning. So for the wait, sorry, let's start with the swimmers. So you have 16 swimmers to choose from. So 16 choose 4. And then for the divers, we have 10 divers to choose from. So 10 choose 2. So with this, you would get 81,900 for our second case. And for our final case, 3 swimmers and 3 divers. So this is just going to be 16 choose 3 times 10 choose 3. So you'll get 67,200. So these are our number of possible selections for each case. And since each case is mutually exclusive, to find our total number of selections, just add all these 3 up. Sorry, it's getting a bit laggy. Okay. So you would get 174,300 as your final answer. Yeah, so I believe this would be final answer for this question. Let's move on to the next question. Okay, so for this question, we are told to find a number of different arrangements. So here we have to use a factorial function as well as p, most likely. So different arrangements of the 9 letters in the word daffodils, in which there is a D at each end. So this is our first condition, and the two Fs are not next to each other. All right, so to do this, let's first consider the first condition, and let's ignore the second condition. So let's do the first condition. So let's draw 9 slots. So 5, 6, 7, 8, 9. Yep. Okay, now let's put a D at both ends. So the way that we do this question is that we first find the number of arrangements where we only consider the first condition, so the number of arrangements where there's a D at each end, and then we find the number of arrangements where there's a D at each end and the opposite of the second condition. So D at each end and the two Fs are next to each other. So we find the number of arrangements by considering those two conditions, and to get a final answer, we just minus both of those arrangements, okay? Yeah, so that's how it works. So let's find the number of arrangements for this case. So the D's are taken care of. Okay, then, all right, so let's write down the number of repetitions. So there are two D's, two F's, OILSA. Yeah, it's just those two repetitions. Yeah, so in this case, whether these are at both ends, we only have to consider the two F's. So we have 7 slots. Yeah, so this is just going to be 7 factorial, and then you divide by the number of repetitions factorial. So divide by 2 factorial. You will get the 2,520. Yeah. Yeah, so this is our first answer. Now we're going to find the number of arrangements where there's a D at each end and the two Fs are next to each other. So whenever you see a knot, you first just consider the case where the knot is not there, right? Okay, so now let's put the two Fs next to each other. Okay, so to like find the number of arrangements where like two letters are next to each other, you have to consider these two letters as one element, okay? Since they can't be separated. So now we only have 1, 2, 3, 4, 5. We only have 5 spots to choose from. Wait, no, sorry, we have 6 spots. We have to also include this since this 2 can move around together. So yeah, 6 spots. Yeah. So this is just gonna be 6 factorial. Yeah, it's just gonna be 6 factorial. Yeah, 6 factorial. Yeah, it's just 6 factorial. There's no other repetitions. And these will remain as they are. So with the two conditions that we have above, it's just going to be 720. And to get the final answer, since we have the knot, you just take this, where we only consider the first condition, and this, where we consider both conditions, except that in the second condition, we just ignore the knot. So this is how you do it. So final answer, we get 1800. So yeah, this would be our final answer for the first part. Let's move on to the next part. Okay, so for this part, we are told to find the probability that a randomly chosen arrangement of the 9 letters in the word daffodils has exactly 4 letters between the two Ds. Okay, so to solve this probability question, we need to know the number of arrangements the number of total possible arrangements. So let's find that out. So that is really easy to do. You just take the total number of elements, factorial, and then you divide by the number of repetitions. And we've established earlier that we have 2 repetitions, which are the 2Ds and 2Fs. So you divide by 2 factorial twice to get the total number of different arrangements. So that's gonna be your denominator in your probability. So yeah, this is a number of different arrangements without any restrictions. Now we're gonna find the number of arrangements where it meets this condition, 4 letters between the two Ds. All right, so let's draw our 9 slots of 5, 6, 7, 8, 9. And let's put the two Ds in any arbitrary place such that there is exactly 4 gaps between them. So you can place them, for example, like this. So the only restriction that we have in here is that the two Ds, they have to have 4 slots, 4 empty slots between them. So therefore, we can consider this as one slot, right? Yeah. So to find out the number of arrangements for this case, you can first. Okay, let's not consider this as one element first. Yeah, let's just consider for this a specific case where the D is here and here. So you can see that there's 4 plus 3 spots available, so 7 factorial. But however, we know this is not the only position that they can be. They can also be here as well as here, and here and here. So that's 3 more positions, and finally here and here. So these are the 4 possible positions that they can be in. So you just have to multiply by 4. Oh, wait. Oh, sorry, I forgot to account for the restriction. Yeah, I forgot about the 2Fs. So don't forget to divide by your duplicates factorial. All right, so 2 factorial divided by 7 factorial divided by 2 factorial times 4, you would get 10,080. So this is the number of different arrangements that we have where there's exactly 4 letters between the two Ds. Okay, and then our probability would just be this final number over our total number of arrangements without any restrictions. So you would get 1/9 as your final answer. And you should leave it like this because it's an exact form. Always try to leave your answer in exact form. So with that, let's move on to the next question. Okay, so for this question, we are told that a fair red spinner has 4 sides. So fair means that the probability for getting each of the numbers on the spinner is the same. So the numbers are 1, 2, 3, and 4. Okay, so red spinner. A fair blue spinner has four sides numbered 0, 1, 2, 3. So the only difference between them is the numbers that they have on their sides. Okay, so when a spinner is spun, the score is the number on the side on which it lands. The two spinners are spun at the same time. And we're told that the random variable x denotes the higher of the two scores obtained. So if the two scores are equal, then the value of x is 0. Okay. So first part, we need to drop the probability distribution table for x. Okay, so before we do that, we need to first come up with the possible values for x. Okay, so to do that, since we are dealing with two objects that are spun at the same time, we can use a table like this where we list all the outcomes of the first spinner. So this is going to be the red spinner. And then over here is going to be the blue spinner. So the blue spinner, we can have 1, 2, 3, 4. And the blue spinner, we have 0, 1, 2, 3. Okay. So the way that this works is that, so here the row we have 1 for red, and 0 for blue. So in that case, the score is going to be the higher number. So this is just going to be 1. And for this case, since we have 1 for red and 1 for blue, they're the exact same. So this is going to be 0. Same for this, 2 and 1. This is 2, 3 and 1, 3. Okay, so here we have 2 and 0. So this is just 2, 2 and 1, 2, 2 and 2, that's 0, 3 and 2, that's 3. 3 and 0, that's 3, 3 and 1, that's 3, 3 and 2, that's 3, 3 and 3 is 0. 4 and 0, this is 4, 4, 4 and 4. Since 4 is bigger than all of those numbers. Yeah, so whatever we got in here, all the numbers that we filled out, these are the values of x. So now we're going to find the probability of obtaining them. Okay, so let's find the probability of getting. Okay, let's start with x equals to 1. Since there's only one case where x is actually equals to 1, which is when we get 1 on our red spinner and 0 on the blue spinner. So yeah, I mean, it's fair. So it's just 1 over 4 times 1 over 4. So this is just 1 over 16. Okay. And then okay, let's do px equals to 0. So we can see that for 0, there is 3 possible cases. So first is where we get 1 for both spinners. So probability for that will just be 1 over 16, since we're told that the probability for getting each number is the same. So probability for getting any combination of numbers is 1 over 16. So since there's 3 of them, just multiply by 3, you'll get 3 over 16. Okay, now let's do 4. Okay, so 4, there is 4 possible cases. So P, probability of x equals to 4. It's just 1 over 16 times 4, since there's 4 possible cases. So 4 over 16, that is just going to be 1 over 4. And lastly, let's do a probability of x equals to 2. So x equals to 2, there's 3 of them. So 1 over 16 times 3 is equals to 3 over 16. And now let's do probability of x equals to 3, which is the highest so far. So there's 1, 2, 3, 4, 5 combinations that give us x equals to 3. So this is 1 over 16 times 5, which is equals to 5 over 16. Okay, so before we go ahead with these probabilities, one condition that you must know is that for all like probabilities in a probability distribution table, they must all add up to 1. So this just means that all the possible cases, the total probability should be equals to 1, which is obviously true. So just doing a quick check. Yep, all of this adds up to 1. So we're good to go and we can start drawing the table. So to draw the table, you put your x values in the first row. So we have x equals to 0, x equals to 1, x equals to 2, x equals to 3, and x equals to 4. And then we have the probability that big X is equals to small x. So you draw the probabilities down below. So it's 3 over 16, 1 over 16, 3 over 16, 5 over 16, and 1 over 4. And yeah, this would be a final answer for the first part. Let's move on to the next part. Okay, so for this second part, we're simply told to find the variance of x. All right, so to find the variance of x, you can refer to your MF19. Under discrete random variables, you would see the formula for variance. So it's just the summation of x squared times p. So this just means that you multiply the probability with your respective x values squared, and then you add, and then you just add all those up for all the x values minus the expectation squared. So with that, for that, we also need to find our expectation, which is just sigma px. So it's just the sum of the product of the probability and the respective x value. Okay, so let's begin. So ex is just sigma xp. So we have x equals to 0. So 0. Probability of x equals to 0 is 3 over 16. And we have x equals to 1 times 1 over 16. So 1 times 1 over 16 times 2 times 3 over 16 plus 3 times 5 over 16. And finally, 4 times 1 over 4. Just type everything into your calculator. You get 19 over 8 for your expectation. Okay, now we're ready to calculate our variance. So variance is just sigma of x squared times p minus our expectation squared. So to find this one, it's the same as finding your expectation, but now you have to square your x value and then multiply probability. And then you add them all up for each of the respective probabilities. Plus 2 squared times 3 over 16 plus 3 squared times 5 over 16 plus 4 squared times 1 over 4 minus 19 over 8 squared. So yeah, again, type everything into a calculator. 2 squared times 3 over 16. 3 squared times 5 over 16. It's 4 squared times 1 over 4. Minus 19 over 8 squared. You will get 127 over 64 as your final answer. So yeah, this is going to be our final answer for this part. Let's move on to the last part, hopefully. Okay, so for this last part, we are told that the red spinner with sides numbers 1, 2, 3, 4 is spun repeatedly. So the number of trials is not fixed. So when that's the case, we're dealing with a geometric distribution. So we need to find the probability that it lands on 4 for the first time before the 8th spin. All right, so this is definitely a geometric distribution. So the only parameter is the probability of success. And in this case, success counts as the spinner landing on 4, and the probability for that is just 1 over 4, since this is a fair spinner. So we just want to find the probability that x is less than 8. Since they told us it has to land for the first time before the 8th spin. And that's what the geometric probability does. It calculates the number of trials required to get that outcome for the first time. All right, so there's a formula for this. Okay, so this is also, since it's a discrete distribution, we can also say that this is same as probability of x less than or equals to 7. And for if you have like a probability in this form, you can simply just use this formula 1 minus q to the power of 7. And the reason why is because if the opposite of doing it in succeeding in 7 tries or less for the first time, the exact opposite is not getting it at all for the first 7 tries, which is basically this, basically failing in all your 7 tries. And yeah, to get the probability for the possible outcome, you have to minus by 1. So this is the logic behind this formula. So that's just going to be 1 minus 3 over 4. That's the probability of failure to the power of 7. And this would be equals to 0.867 to 3SF as the final answer. So yeah, this would be our final answer for this last part as well as the entire question. Let's move on to the next question. Okay, so for this question, we're told that Chen has 3 boxes. Box A contains 5 counters, of which 3 are white. So we might need the colors later on. Okay, sorry, give me a while. It's lagging a bit. 3 are white and 2 are yellow. Oh no. Okay, let me pause this recording. Okay, so as I was saying, let's continue. So box W contains 4 red marbles and 3 blue marbles. Box Y contains 5 red marbles and 3 blue marbles. Okay, so the second paragraph, they tell us what's actually like going on in here, what they're doing with the marbles and counters. So Chen chooses one counter at random from box A. If the counter is white, he chooses two marbles from box W at random and without replacement. So this is a keyword. Without replacement just means he takes the marbles and he doesn't put it back into the box. If the counter is yellow, he chooses two marbles from box Y at random and without replacement. So same for Y and W and Y, they don't put back the marbles after taking them. Okay, so first part, we need to draw a fully labeled tree diagram to illustrate this information, including all the probabilities. Okay, so we have, so first, they start out by choosing a counter from box A. So there's two possibilities in the first stage. First possibility is that you get a white counter. So white counter, there's 3 out of 5. So probability is going to be 3 out of 5, bracket W. And then the rest are the yellow counters. So the probability for that is 2 out of 5. So 2 yellow. Okay, and then if the counter is white, he chooses two marbles from box W at random and without replacement. Okay, so for the first marble from box W, there's two possibilities, either a red marble or a blue marble. So, okay, I guess, wait, oh no, not again. Oh, okay, so box W, probability of choosing a red marble. So 4 plus 3 is 7. So red marble probability is 4 out of 7. Okay, that's red. Okay, and then for blue marble, it's just 3 over 7. Oh, what's going on? Three over 7. That's for blue. Okay. And then after choosing from box W, the first marble, we also need to choose the second marble. So second marble again, there is two possibilities, but now there's going to be 6 marbles instead of 7 marbles. So if you choose a red marble at first, you would only have 3 red marbles to choose from. So this is just going to be 3 out of 6. Oh my, what's going on? Red. Okay, let me not draw the probabilities there. Okay, 3 out of 6. Okay, red. And then blue. You would still have 3 blue marbles, so 3 out of 6. Okay. And then if you chose a blue marble at first, you'll still have 6 marbles in total, but you would still have 4 red marbles. So this is going to be 4 over 6. And for blue, it's going to be 2 over 6, since there's 6 marbles in total. So this is for box W. And now for box Y, that is, if the counter is yellow, you have to take 2 marbles from box Y. So let's calculate. So there is 5 red marbles and 3 blue marbles. So red marbles from box Y is 5 over 8. Wait, oh no. 5/8, and blue marbles is 3/8. Okay, and then if you choose a red marble in the first one, you can also get in the second one. So if you get the red marble as your second marble, you will have 7 marbles in total and 4 red marbles. So it's 4 out of 7. And then for blue marbles, you would have 3 blue marbles, so 3 out of 7. However, if you choose a blue marble as your first marble, you would have 5 red marbles to choose from. So for red, it's going to be 5/7. And for blue, it's going to be 2/7 since you chose a blue marble in your first try. And yeah, these are all our possibilities. Okay. Yeah, so this is our final answer for this first part. Let's move on to the next part. Okay, so for the second part, we need to find the probability that 1 red marble and 1 blue marble are obtained. Okay, let's refer back to our tree diagram. So to get 1 red marble and 1 blue marble, so we are going to look at branches where we have B and R, or R and B. So this is the first branch. Okay, I'm going to highlight in black. So this is, oh wait, sorry. I meant to do it in black. Okay, so this is the first branch, RB, BR, and from box Y, RB, and BR. Yeah, so these are our 4 branches. Okay, so we are gonna find the probability from each branch. Okay, and then we're gonna add up all the probabilities from the individual branches to get our final answer. Let me change back. All right, so the first one, RB, it's 4/7 times 3/6. Okay, so 4/7 times 3/6 plus 3/7 for BR, 3/7 times 4/6. 3/7 times 4/6. And then the third branch from Y, RB, is 5/8 times 3/7. 5/8 times 3/7. And finally, the BR branch from Y, 3/8 times 5/7. 3/8 times 5/7. Okay, so just type all of this into your calculator. 7 times 3/6 plus 3/7 times 4/6 plus 5/8 times 3/7 plus 3/8 times 5/7. Wait. Let me see. Hmm. Okay, give me a while. Hmm. Oh, okay. I forgot to include the probability of um getting a white counter and a yellow counter. Okay, yeah, so you have to multiply all the probabilities from all the branches. So our first two RB and BR, they're both from W, so you have to multiply 3 over 5, which is the probability of getting a white counter. Okay, so just 3 over 5 multiply. And then we have from Y, so multiply 2 over 5, 2 over 5, and yeah, multiply by 2 over 5 again here. Yeah. Yeah, now we're ready to find our probability. Okay, so the final answer is going to be 39 over 70. Okay, right. So this would be our final answer for this part B. Let's move on to the final part. Okay, so for the last part, we need to find the probability that a white counter is chosen from box A, given that one red marble and one blue marble are obtained. So this is a conditional probability question. So the first thing you should do is to write it in the conditional probability notation. So this is the keyword in here. So we want to find the probability that a white counter is chosen from box A. So probability that we get W, given that we get one red and one blue marble. So to get the conditional probability like this, the formula is you get the probability of W union, not union, intersect, so W and red and blue. So in words, this is going to be the probability that we choose a white counter and we get a red marble and a blue marble over the probability of getting a red and blue marble. So this one we have already found out in the previous part. So we just have to find out the numerator. So the probability of getting white and red and blue, go back to the tree diagram. So this is white, this is red, and this is blue. So you can see that we just have to focus on two branches, the WRNB and WBR. So yeah, that is just gonna be 3 out of 5 times R and B. So R and B is 4 over 7 times 3 over 6. 4 over 7 times 3 over 6 plus 3 over 5 times. Okay, so B and R is 3/7 times 4/6. 3/7, 7 times 4/6 divided by the probability of getting a red and blue marble, which we already found out is 39/70. Over 70. Okay, so just type all this into your calculator. You would get 8/13 as your final answer. Yeah. Oh my goodness. So yeah, this would be our final answer for this last part as well as the entire question. Let's move on to the next question. Okay, so for this question, we are told that last Saturday, a cycling competition for teams of 11 cyclists took place. For each cyclist, the time taken to complete the course was recorded to the nearest minute. The times taken by the cyclists from two teams, the Linnets and the Puffins, are shown in the following table. Yeah, so we're given the timings of each member from each team in here. So first part, we are told to draw a back-to-back stem and leaf diagram to represent this information with linnets on the left-hand side. Okay, so to draw a stem and leaf diagram, a back-to-back, first you draw the center column like this, and then you draw the top rows like this. So linnets are supposed to be here, and puffins are supposed to be on the right-hand side. Okay, so the way a stem and leaf diagram works is that you take one digit, so the tens digit in our case, you put it in the stem, which is right here, and then the ones digit, you put it to the left or right of the stem, depending on which group it's from. So let's start with everything with 4 as the tens digits. So can put 4 here. All right. Okay, let's see. All right, everything is in ascending order. For linnets, that we only have 48. And for puffins, we have 45 and 49. So you can write 5 and 9. And and for stem and leaf diagram, you should never forget to write down your key. So to write down the key, yeah, you can take like a specific part of your stem and leaf diagram. So I'm going to take what I've written already. So 8, then the stem, we have 4. And then on the other side, we have 5. So 8, 4, 5. So you're supposed to write down key here. So key 845 represents represents uh it's so laggy. Represents 48 minutes for linnets. Oh my. Linnets and 45 minutes. for puffins. Yeah, so this is how you're supposed to write down your key, otherwise you won't get the full marks. So yeah, now we can continue writing down the rest of the data. So we have 5 as a tens digit, we also have 6, and finally we have 7. So let's finish the lineates first. So for lineates, we have 51, 54, and 57, all the way to 59. So 51, 54, 57, 59. And we also have 60, 64, twice, 65, and 68. So 60, 64, 64, 65, and 68. And finally, we have 70 for lineates, 70. And then for puffins, we have 51, 55, 55, 58, 59. So 1, 5, 5, 8, 9, then 62, 64, 64. So 2, 4, 4, and 74. Yeah, so this would be a final answer for the first part. Let's move on to the next part. Okay, so for this part, we are told to find the interquartile range of the times taken by the lineates. Okay, so to find the interquartile range, we need to find the Q1 and Q3. So Q1, that's basically the 25th percentile, and Q3 is the 75th percentile. Okay, so let's count how many data points we have. Okay, never mind, we're given. There's 11 data points. So your Q1, oh wait. Okay, so the Q1, to get which data point it is, just take 1 over 4 times 11 plus 1. So this is going to be your third data point for Q1. As for Q3, you just multiply it by 3 over 4, since it's a 75th percentile. And for this, you're going to get your 9th data point. Yeah. So to get your final answer, just minus Q3 and Q1. So Q3 is the 9th data point. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 9th data point is 65. And the third data point is 54. So subtracting these will get us 11 minutes as our final answer. So this is our IQR. Let's move on to the next part. Okay, so for this part, we are told to draw a box and whisker plot to represent the information for the lineates and the puffins. All right, so to draw a box and whisker plot, you have to know 5 pieces of information. You have to know your median, your Q1 and Q3, and you have to know your maximum and minimum data points. Okay, so let's start by listing all of those out for each group. So lineates, oh my. So lineates, we already we already did Q1 and Q3. So Q1 is 54. Oh my, 54. Q2 is is going to be in your sixth position. So 1, 2, 3, 4, 5, 6. So that's basically 60. And then Q3, we already figured out that is going to be 65. Sorry. Oh my, 65. And then the minimum is 48, maximum is 70. 8 max is 70. And then for the puffins, the positions are still the same for our Q1 median and Q3. Yeah. So Q1 is still the third data point. Yes, 51 for puffins. 50, my goodness. 51. And then median or Q2 is the sixth data point, which should be 58. Yep, 58. And Q3 is Q3 is ninth. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is 64. Yes, that's 64. And minimum is 45 and max is 74. And max is 74. So yeah, these are our critical points. Now we're ready to sketch. Okay, so let's set the scale up in this way. So we can start from 14 here. And then this would be 50, 60, and 70, and 80. So this is 50, 60, 60, 70, and 80. So for linettes, I'm gonna do for linettes in blue. So minimum is 48. So it's basically 2 boxes away from 50. I'll do it at the top. So this is for Lynette. And then Q1 is 54. So that's 50, 51, 52, 53, 54. And then Q2 is 60. And then Q3 is 65, which is halfway between 60 and 70. Okay, and then just draw a box between Q1 and Q3, and max is 70. And then draw a line connecting the minimum in Q1 and the maximum and Q3. So this is for Lynette's. Don't forget to label it in the exam. For me, I'm using different colors. Okay, so now for puffin, the minimum is 45, which is halfway between 40 and 50. So it starts from here for puffins. And then Q1 for puffins is 51, which is 1 square to the right from 50. And then Q2, which is 58, 2 squares from 60. Okay. And then Q3, 64, which is here, and 74, which is the max. So let me just connect all these first. Okay, and 74, so 71, 72, 73, 74. It's right here. Okay, so now just connect. And yeah, so we are done with the box and whisker plots for both linnets and puffins. So yeah, this would be our final answer for this part. Let's move on to the last part. Okay, so for the last part, we're told to make one comparison between the times taken by the linnets and the times taken by the puffins. Okay, so if you refer to your box and whisker plots, you can see that the range for the puffins is a lot more than that of the linnets. So therefore, we can say that times taken by puffins is more spread out. Puffins is more spread out. Than for linnets. And yeah, we can stop here for this question. So this is our answer for our final part. Let's move on to the last question. Oh, okay. So for this question, we're told that the times taken by OB to walk to work each morning are normally distributed with mean 14.8 minutes and standard deviation 1.5 minutes. So we need to find the probability for the first part, we need to find the probability that on a randomly chosen day, OB takes more than 15.6 minutes to walk to work. Okay, so so this is a normal distribution with mean 14.8 minutes and variance 1.5 seconds squared. So we want to find the probability, X normally distributed. So we want to find the probability that X is more than 15.6. So we can rewrite this as 1 minus the probability of X less than or equal to 15.6. And this probability we can now convert it to a Z-score. So to convert it to a Z-score, change the X to a Z, and you have to minus the mean first, so 15.6 minus the mean, 14.8, divided by the standard deviation, 1.5. Okay, and now you can simplify that. So 15.6 minus 14.8 divided by 1.5. You have to express it to 3 decimal places. So in that case, this is going to be 0.533. And now you can express this as 1 minus pi, 0.533. 533. Okay. So to find the probability of 0.533, you need to go to your normal distribution tables. So 0.533. So 0.5 is here, 3 is here. So this is the first answer. And then since we have a 3 at the end, we are going to take the 3 here and then see what number we have to add. So we need to add 10. Since 0.5 and 3, you get this number. So the probability is 0.7019 plus 0.0010. Yeah. So this is going to be 1 minus 0.7019, 0.7019, minus 0.001 minus 0, gosh, oh my, 0.001. Yeah, just type it into your calculator. You would get 0.297 as your final answer to 3SF. So yeah, this would be a final answer for this first part. Let's move on to the next part. Okay, so for this second part, we are told that on 90% of days, OB takes more than 10 minutes to walk to work. So we need to find the value of T. All right, so first let's write down the probability. So the probability that X is more than T is 90%. So 0.9. Oh, wait, what? Sorry. Oh, okay. All right, so 0.9. All right. Now let's convert it to 1 minus so that we can standardize it. So 1 minus probability of X less than or equal to T. Is equals to 0.9. All right. Now let's make probability that X is less than or equal to T as subject. And we would get that equals to 0.1. And now we're ready to standardize it. Okay, so there's a probability of Z less than or equal to T minus the mean, which is 14.8 over 1.5, which is the standard deviation, equals to 0.1. And now now we can convert it into phi. T minus 14.8 over 1.5 equals to 0.1. So now we have to use the normal distribution tables in reverse. Okay, so now instead of looking at the values here, we look for our phi value, the 0.1, we look for it in here, and then we try to find the closest Z value. Okay, however, if you notice, the lowest value for the values in here is actually 0.5. So that means our Z score is actually negative. All right, so we need to factor out a -1 from here and rewrite this as 1 minus pi 14.8 minus t over 1.5 equals to 0.1. So phi 14.8 minus t over 1.5 is equals to 1 minus 0.1, which is 0.9. Okay, now we are ready to find it. So 0.9, look for the number closest to and less than 0.9. That is going to be this number right here, 0.8997. To make it 0.9, you just have to add 3 to the last digit. Wait, 3. Why is 3 not here? Hmm. Give me a while. Okay, so if your area or your p-value isn't in here, you can check in here. So we are given the critical value, so we can see that 0.90 is here. And when p is 0.90, z is 1.282. Yeah, so we can equate this. Oh my, 15.8 minus p over 1.5. 1.5 equals to 1.282. 1.282. Okay, now we can solve for t. So t is just gonna be 14.8 minus 1.5 times 1.282 equals to 12.923 SF. Okay, yeah, so this is our final answer for this part. Let's move on to the last part. Okay, so for the last part, we're told that OB walks to work 5 days a week for 45 weeks in a year. So we are told to calculate the number of days in a year that we would expect OB to take within 1 minute of the mean time to walk to work. Okay, so within 1 minute of the mean time, so that's the probability that x is between, so the mean time is 14.8. So within 1 minute of that, it's between 13.8 and 15.8. So if you standardize it using the Z-score, you're going to be getting 1 over the standard deviation, which is 1.5. And lower limit is just going to be negative of that, negative 1 over 1.5. So 1 over 1.5 and round it off to 3 decimal places, so 0.667. Yeah, so 0.667. Yeah, so now we're gonna evaluate this probability first. So this is basically the same as the probability of Z less than 0.667 minus the probability of Z less than negative 0.6666 7. So we can now convert them into functions of phi. Phi 0.667. And since this one is negative, if we convert it to phi, we can just straight away write down -1 plus phi 0.667. So this is just going to be 2 times phi, oh my gosh, sorry, phi of 0.667 minus 1. So let's use our normal distribution tables to find 0.667. So there's 0.66. So we have this 0.7454 and 7 as our final digit, where we need to add 23. So 0.7454 plus 0.0023. Okay, so oh my goodness, 0.7454 plus 0.0023 minus 1 is 7454 and plus 23. Yeah, so this is, we're just going to leave it unsimplified since we don't want the probability, we want the number of days. Okay, so I'll just leave it in exact form. So exact form, I got 2477 over 5,000. So here they ask for the number of days. So to do that, just multiply by the total number of days in a year, which is basically 5 days a week. And in a year, he works for 45 weeks. So the probability times 5 times 45. And since they want the number of days, you need to round off your answer to the nearest whole number. All right, so I got 111 as my final answer, nearest whole number. And yeah, this would be our final answer for this part, as well as the entire question. And we have also come to the end of this paper. So I hope you found this video helpful. If you did, please make sure to like and subscribe to this channel for more future past paper solving videos for A-level maths and further maths. If you have any questions, queries or doubts or any feedback, feel free to leave them down in the comments below. And a side note, I actually am a tutor with Under Smile Tutoring. So if you're doing A-level mechanics, and A-level statistics, probability and statistics 1, I will have the link to sign up in the comment section. It's going to be pinned as well as in the description. So if you're interested, please check that out. And with that, I'll see you again next time. Okay, thank you.